Based on decades and decades of research and a lot of observations across the universe, even to date, Earth is still the only known planet to us that definitely contains life. And that's despite the fact that thousands and thousands of different exoplanets have already been confirmed. But despite these large numbers, it's really only the handful of exoplanets scientists are currently trying to investigate because of a relatively high potential for extraterrestrial life to maybe exist there. And well, in this video, we're going to discuss a relatively recent and somewhat intriguing discovery that was done by using a very unique method when looking for exoplanets. But even more interestingly, when scientists discovered this planet, they realized it was actually in the habitable zone of a star extremely similar to our Sun. And so let's talk about this recent study and these recent discoveries. But first, let's actually start with some of the previous discoveries, just to help you understand how all of this is surprisingly extremely rare. Although first, a quick clarification. Here we're only talking about planets located in habitable zones of various stars. And that's because, based on the example of planet Earth, we know life can definitely exist if a planet is at a certain distance away from the star. And so depending on the star, this zone is going to be in very different locations. And so until we actually find life somewhere out there, for example maybe on some other planet like Venus or Mars, or maybe even on one of the moons of Jupiter, we're still going to have to rely on this habitable zone because this is the only certainty we have. This seems to be the only location in the star system where liquid water can exist and conditions can be perfect for life to evolve. And well, based on what we've discovered so far from other star systems, and based on what we know about our own galaxy, today it's believed that at least 40 billion Earth-like habitable planets, or at least Earth-sized planets, could possibly exist somewhere in the Milky Way, basically orbiting in these habitable zones around Sun-like and red dwarf stars. Except that in some of the recent studies, scientists also realized that maybe red dwarf stars, which are the most common types of stars in a galaxy, could be just a little bit too active and possibly too dangerous for any life to survive. And so if we ignore red dwarfs, and if we only focus on Sun-like stars, at least 11 billion such planets should be hiding in the Milky Way. But as I mentioned, surprisingly, only a handful of these planets have so far been confirmed in the vicinity of the solar system. And so out of several dozen habitable exoplanets discovered to date, only a very small number seems to orbit Sun-like stars. And there are so few of them that it's only going to take me a couple of minutes to basically cover all of them. Here's the illustration for the first one, Kepler 452b, previously referred to as the Earth's cousin in some of the initial press releases. And in this case cousin because it's actually much more massive than Earth, at least 5 masses of planet Earth, but orbiting at a similar distance away from the star, and back then representing only the second planet discovered around a G-type star located in the habitable zone, although this was back in 2015. Since then, a few more planets have been discovered. But the problem is that this planet is also really far, over 1800 light years away from us, so studying this would be very challenging. And so in contrast, we have this, Tau Ceti F, another super-Earth orbiting a Sun-like star, but much closer to us, only 12 light years away, around a famous star known as Tau Ceti. You can actually learn about the star in one of the videos in the description, because it is a very exciting star system and seems to hide quite a lot of mysteries. And so at 4 Earth masses, and potentially slightly colder than planet Earth, this planet is pretty exciting. Then number 3 is HD 20794d. This is a little bit farther at 20 light years away, but surprisingly is also a super-Earth, at least 6 times more massive than planet Earth. And this one is also unique because it only passes through the habitable zone once in a while and seems to contain a somewhat eccentric orbit. The star system also contains a few other planets, and so here there are quite a lot of mysteries as well. And then we have Kepler 22b, representing the smallest planet discovered in the habitable zone at only 2.3 sizes of planet Earth. But it's also 630 light years away from us, and potentially a little bit hotter. This was actually assumed to be maybe Venus-like and not Earth-like. We also have some other candidates like Kepler 1606b, another super-Earth orbiting 2 stars, but these haven't been confirmed yet, so we don't really know if they exist. But in a nutshell, that's pretty much it. We essentially only have these 5 exoplanets orbiting in the habitable zone of G-type stars, stars similar to our Sun. And so finding a new planet is obviously super exciting. And that's essentially what happened here. except that this time it was discovered using a really intriguing method. A method referred to as TTV, Transit Timing Variations. And here this is somewhat tricky. We're essentially looking at very slight variations in orbit, which can usually happen because of one of two things. Either some kind of a second planet in the orbit of the star that changes the orbital parameters just a little bit every time the planet passes in front of the star, or possibly some kind of an exomoon that's pulling on the planet as its shadow passes in front of a star and as the shadow is being measured. And while obviously in the past, the transit method was how we discovered most exoplanets, but in some extremely rare examples, it was actually possible to discover other exoplanets by looking at these very minute transit variations. And in this case, this is a method that can help us discover planets that don't actually create a shadow in front of the star and that seem to have a slightly more inclined orbit. And the first time this method was used to find planets was back in 2012. This was used to discover planets in the Kepler 9 system. And because this method can be pretty accurate, it can also be used to indirectly measure the mass of the exoplanet, which is actually how the planets in the TRAPPIST-1 system had their masses measured over time. Here this was done by measuring the transit variations, and by then using modeling in order to determine the overall mass for each of these planets. But this time researchers were actually able to apply this to a slightly different star system, a star system similar to our Sun, and a type of a system that usually does not have a lot of these transits, simply because in most cases these planets orbit really far away. And so because of this major geometric constraint due to the orbital parameters, it's usually very difficult to find planets around G-type stars, which is actually one of the main reasons why so far no planet has been officially confirmed around the nearby Alpha Centauri. Alpha Centauri contains a Sun-like star and a K-type star. Both of them are pretty exciting, but so far none of them seem to contain anything. And that's because usually in G-type systems, or in Sun-like systems, transits are just too shallow and short-lived, and so it's very difficult to see them. But we knew that there was at least one planet here detected by Kepler back in 2016. And this was a planet extremely similar to Saturn in mass and potentially composition, except that it was orbiting much closer. It took approximately 40 days. So this is basically a kind of a hot Saturn. And so in this case, by analyzing the transit variation signals from the Kepler 725b, the researchers from the Chinese Academy of Sciences definitively confirmed another exciting planet. And here the accurate observations from the Yunnan observatories allow them to definitively determine the mass and the location of this planet. The mass once again makes it a super-Earth. This seems to be approximately 10 masses of planet Earth, making this one of the larger planets discovered in the habitable zone. But its orbit is approximately 208 days, putting it in a very similar position to Venus. And so here it's potentially also a little bit on the hot side, receiving at least 1.4 times more radiation than planet Earth. But it is nevertheless a really exciting planet, because this is basically planet number 6 orbiting a Sun-like star in the habitable zone. But even more importantly, by using this method, we can now start discovering additional planets, because this definitively demonstrates that by using the transit variation techniques, it seems to be quite possible to discover low-mass planets, even orbiting in habitable zones of Sun-like stars, and even at these ridiculous distances of almost 1,000 light-years away from us, which would be otherwise impossible using any other method, mostly because these planets don't really show any other signs and are far enough from the star that they barely produce any shadow or even any pull on the star itself. And so here even the famous radial velocity method would be extremely challenging to use, especially because a lot of these stars are really massive and a lot of these planets are not. But if you look at this from a different perspective, this is only the 6th planet out of potential 11 billion out there. And so we're definitely just getting started. But obviously once we have some more updates, or once researchers discover something else, we'll come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support the show on Patreon where you can actually find quite a lot of additional videos, and some videos you might have not seen before, and of course videos without any ads. Maybe support this channel by joining the channel membership, or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.